One of the most common reactions that we personally do with any of these molecules is a combustion reaction, especially with the alkanes and the alkenes. One of their main uses is through combustion, most of those hydrocarbon molecules. So we're going to look at combustion, and it should be reviewed mostly from Science 10 Chem 20, but we're going to add a little bit of a detail to it that changes it just slightly. So let's start with just easy, complete combustion that you guys have already learned. So if I have something like octane, C8H18, I know that in order to burn that, I'm going to need oxygen, and I'm going to produce carbon dioxide, and I'm going to produce water. And then you'd have to go through and balance this. Now, in order to do it, if you look at this, I can kind of see now that I'm going to have to double it. If you worked your way through this, you'd see that we're going to have to go, if we're going to balance with whole numbers, that's going to need to be a 2. You're going to get 25, 16, and 18. So just to speed things up, I'll just throw that in. That's complete combustion. And that kind of combustion happens whenever you have enough oxygen to make carbon dioxide as a product. And so you're familiar with that one. Now, what we didn't teach you probably in Science 10 and Chem 20 is that if you don't have enough oxygen, you don't get carbon dioxide as a product because there's not enough oxygen to make it. So if I do the same reaction, C8H18 plus oxygen, but if there's not enough oxygen, it's limited, it's not an oxygen-rich environment, instead of producing carbon dioxide, we produce carbon monoxide and water. So this is incomplete. And let me just balance this for you. It's 2, 17, 16, 18. So you can see less oxygen is required to make carbon monoxide than carbon dioxide. So this is why in your homes you might have carbon monoxide detectors, because if you have an appliance that's burning natural gas or something like that, and it doesn't get enough oxygen, you're going to start producing carbon monoxide, which is colorless, odorless, tasteless, and very, very deadly. So you need to have a carbon monoxide detector so that if something goes wrong with those kind of appliances, you can detect something like this starting to show up. Oop, spell that right. The other thing is if you have really poor oxygen, and let me put a caveat here. Those two right there are the ones you need to know. If I ever say on a test or an assignment, complete combustion, or even if I say oxygen-rich environment, it's going to do complete. If I say anything that hints towards there's not enough oxygen or it's an oxygen-poor environment, do incomplete. Those are really the only two I've ever seen that I'm going to put on a test for sure, and that I've seen on a diploma, which you don't have to worry about. So the next one is if it's really poor oxygen, the next step is the same fuel, and let's just balance as we go. This time it's only 9 oxygen, but instead of that you just get 16 carbons and 18 water. So you can see here the difference that makes. You either need 25, 17, or 9 oxygen. Now in a, excuse me, in an appliance like a furnace, it's designed to be very efficient. It's designed to have the right amount of oxygen flow. So if everything is working properly, you should have nearly 100% complete combustion. But if you go outside and you build a campfire, every part of that fire is probably doing a different reaction. So in reality, all 3 of these are probably happening simultaneously. You're getting a little bit of complete combustion, a little bit of incomplete, and you're probably getting some of that even really poor oxygen combustion that's leaving the carbon. And that's why, like, if you stick a hot dog stick in the fire, you might get some of that black soot on the end of the hot dog stick. That's just from parts of the fire that aren't getting enough oxygen when they're burning. It's also where you get smoke. Some of that carbon is just in the smoke itself. It's actually just unburned carbon and fuel that's leaving because there wasn't enough oxygen. If you have a fire with adequate amounts of oxygen, there's no smoke. It's a completely smokeless fire if it gets enough oxygen. So if you're building a fire, campfire or something, and you're getting lots of smoke, your parts of your fire are starved for oxygen, and that's what's causing that smoke. But like I said, I would only really worry about the top two. If the question says anything about an oxygen rich or having lots of oxygen, do complete carbon dioxide and water. If they say it's limited oxygen, then I would do carbon monoxide and water. They would have to give you a pretty strong hint, like tell you that straight carbon was being produced or something, to make me do the bottom one. Because there's no way for you to necessarily differentiate by a term like limited oxygen whether they mean this limited or this limited. So I'm not going to get that picky on the test, but just be aware that change can happen. Now the last thing, just in the bottom of your notes, and this, we may not use this a ton now, but it does become a little bit helpful in the next unit, is the idea of balancing using fractions. So let me show you this same reaction, and let me show you how to balance it with not whole numbers, and how sometimes it can actually make things easier. It'll be necessary in the next unit. In this one, it just might make some things easier for you. So when you're balancing this, let's say we start with our carbons. So I have 8 carbons. There we go. I have 18 hydrogens, and there's a 2 over here, so I'm going to put a 9 there. Now I have all my carbons and all my hydrogens. I just have to balance my O's. So if I look here, I have O2, and there's 8 of them. That's 16 O's. And if I look over here, I have 9. So I have 16 and 9, so I've got 25 oxygens. Now this is normally where you'd say, oh crap, it's an odd number, I'm going to have to double everything and then go again. But if you take an O2, remember that an O2 is just 2 oxygens stuck together like this. So if I use a fraction and I say half of an O2, well, half of an O2, if I take off the other half, is just a O. So now that I've halved the O2, how many O's do I need? I need 25. So that's another way to balance. Like I said, not a huge deal if you don't quite get that right now, but we're going to do a lot more of that in the next unit. So it might be helpful just to introduce it here a little bit. Put that note at the bottom of the page there. Other than that, that's it. Make sure you understand combustion and what happens if you have not enough oxygen and how it changes your balanced reaction. But that one hopefully is fairly straightforward for you. So if you have any questions or problems with it, just let me know.